Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 9.2, which is going to deal with data distributions and outliers. So for today's lesson, we have two learning goals. Our first learning goal is that you will be able to create a dot plot and identify an outlier. And then lastly, you will be able to determine the distribution of a data set, whether it is skewed to the right or to the left, and then if it is symmetric. So that's going to be our two learning goals for today. And with that said, let's go ahead and get into our notes for today. So first of all, a dot plot. A dot plot is a data representation that uses a number line in x's or dots or other symbols to show frequency. Dot plots are sometimes called line plots. So what we're going to do is take a number line and we're going to go through and either put a dot or an X for every time that that number occurs. And if it occurs more than once, we just keep adding dots or X's above that number. Next, so we talked about you'll be able to create a dot plot and identify an outlier. So let's talk about what an outlier is. An outlier is a value in a data set that is much greater or much less than most of the other values in the data set. Outliers are determined by using the first and third quartiles and the IQRs. Now, general rule of thumb for an outlier is it's an extreme value that's either way larger than the data set or it's an extreme value that's way smaller than the data set. Okay, if I have a whole bunch of numbers 1 through 10, and then all of a sudden I throw a number that's 100, okay, 100 is way larger than numbers 1 through 10, so that would be considered an outlier. Now, there is a technical way to go through and calculate if something is an outlier or not, and that would be doing this. So a data value x is an outlier if x is less than quadrant 1, Q1, or not quadrant 1, quartile 1, sorry. So we can determine if x is an outlier if x is less than the first quartile minus 1.5 times the IQR. So that's that interquartile range. Or if x is greater than the third quartile plus 1.5 times the IQR. So I'll point that out on how that's technically done. Most of our time, though, is just going to be spent by looking at a set of data and just determining, just from looking at it, if that number appears to be an outlier. So with that said, let's go ahead and get into example 1 for today. And example 1 for today is going to have us go through and create a dot plot for the data set using an appropriate scale for the number line, which has been given to us. And we need to determine whether the extreme value is an outlier. And for the matter of our purposes, we're just going to look at the data in the outlier or determine if it has an outlier. So, with that said, for part A, it says, suppose that the list of salaries from the Explorer is expanded to include the owner's salary of $150,000. Now the list of salaries is 25, 30, 35, 35, 35, 40, 40, 40, 45, 45, 50, 60, and 150. So that's their salary per thousands of dollars. So we're going to go through and create a dot plot of this data. So first up, we have 25. So 25 is going to be represented here, and I'm just going to put a dot at that number. So 25, then we have 1 at 30, then we have 1, 2, 3 at 35, so we're going to do 1, 2, and then 3. So we got 1, 2, 3. 40 also has 1, 2, 3. 45 has 2, so we're going to put 2 dots at 45. 50 has 1. And then 60, there's only 1. And then we also have 150, so we're going to put a dot all the way down at 150. So that is how we're going to create a dot plot. We just have to go through and represent how many times it occurs, or that number occurs on the number line. You can use an X if you would prefer. I'm going to use dots for this. So you have successfully created your first dot plot. So now that we have our dot plot, they want us to go through and determine if the extreme value is an outlier. So our extreme value in this case would be 150. Just by looking at this dot plot, does 150 appear to be an outlier? It does, and it is because 150 is vastly extreme compared to all the numbers residing between 25 and 60,000. 150,000 is definitely an extreme number in this case, and if we wanted to go through and specifically talk about how this is an outlier, if I used the how to identify the outlier part, if I found my third quartile to be 47.5 and my IQR is 12.5, 150 greater than 47.5 plus 1.5 times 12.5, we end up with 150 is greater than 66.25. Because that is true, 150 is technically considered an outlier. But don't worry about, I'm not going to have you really focus on that. I just want you to realize that 150 is an extreme value, okay? Because it's way larger than our data set. And that is how we do part A. So part B wants us to go through and also make a dot plot. We're going to use the same salaries from part A that we just did above, except this time the owner's salary is $65,000. So we have our numbers as these. We need to go through and make a dot plot, and then we're going to go through and consider if 65 is an outlier. So if we start with 25, then 30, then we have, again, 3 at 35. We have 3 at 40. We have 2 at 45. We have 1 at 50. 1 at 60. And then 1 at 65. So, using our dot plot, again, you have thus created your second dot plot. Does 65 appear to be an outlier of this data set? Is 65 a vastly extreme number, larger or smaller than the data set? It is not, so 65 is not going to be an outlier. So in this case, this is a normal number. It's not an outlier. It's not a number that's much greater or much less than the data set. So this number is okay. So for example 1, that is all we have to do is just go through and create a dot plot and then determine whether or not a number is an outlier. So again, dot plots. You just go through and make a dot or an X or some other shape each time that number occurs on the number line, and then that's how you go through and do it. So with that said, we're going to go ahead and move on to example 2. And example 2 wants us to go through and calculate the mean, median, IQR, and standard deviation for each data set, and then go through and compare the data. Now, I have gone through and provided the standard deviation for us on this one. That way we don't have to run through and do it. What you would have to do is go through and put these numbers first in order from least to greatest to figure out the mean and the IQR, or the median and the IQR. To figure out the mean, we're going to add all the numbers up and divide by how many there are. So let's go ahead and figure out the mean for both of these data sets. We look at game show 1, we're going to do 18 plus 20 plus 25 plus 48 plus 35 plus 39 plus 46 plus 41 plus 30 plus 27. When I add all of those up, we end up with 329, and to figure out the mean, we have to divide by how many there are. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we're going to do 329 divided by 10, and we get a mean of 32.9. Now, if we figure out the mean for game show 2, again, we're going to go through and add all these numbers up. So 24 plus 29 plus 36 plus 32 plus 34 plus 41 plus 21, and I put 24 plus 38 plus 39 plus 26. We end up with 320. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to divide that by 10, and we end up with a mean of 32. So we now have the mean for both of the data sets, and the mean goes back to section 9.1, where you go through and add all the numbers up and divide by how many numbers there are. Now, to figure out the median, we need to go through and put the numbers in order from least to greatest for both of these data sets. And then we have to find the middle number to figure out our mean. So for game show 1, our order is going to be 18, 20, 25, 27, 30, 35, 39, 41, 46, and then 48. So to find the mean for this data set, we're just going to work from the ends towards the middle. So 18 and 48, 20 and 46, 25 and 41, 27 and 39. And we end up with a number that's going to be between 30 and 35. So to figure out our mean, if you think back to the previous section, or the median, sorry. To figure out the median, our middle number, we're just going to add these two numbers together and then divide by 2. And we end up with a median of 32.5. So our median would be right there. Next, let's go ahead and find the median for game show 2. So we need to go through and put these numbers in order from least to greatest. So if we go through and do that, we have 21, 24, 26, 29, 32, 34, 36, 38, 39, and then 41. So to go through and find our median, again, we're going to work from the ends towards the middle. So 21 and 41, 24 and 39, 26 and 38, 29 and 36. and I end up with 32 and 34, so a number between those two is going to be my median. So to figure that out, if we're between 32 and 34, all we have to do for this is do 32 plus 34, divide by 2, and we end up with 33. All right, so now I have my mean, where we went through and added all the numbers up, divided by how many there are. We found our median by putting them in order from least to greatest, and then found the middle number. Now we have to figure out the IQR. And to figure out the IQR, we're going to take the third quartile, subtract it by the first quartile. So to find the third quartile, or the first quartile, remember we're going to ignore the second half of the data, including the median. So what we're going to do from here is find our middle number. And if we find our middle number by working in, so 18 and 30, 20 and 27, and then we're going to end up at 25. So 25 is going to be the first quartile. Then to find our third quartile, we're going to ignore the first half of the data, including the median, and then we're going to work our way in towards the middle. So 35 and 48, 39 and 46, and then we end up at 41. So then to figure out the IQR, we're going to take the value for the third quartile, 41, and we're going to subtract it by the value of the first quartile, which in this case is 25. So 41 minus 25 is going to give us an IQR of 16. And then we're just going to go through and do the same thing for the second data set. So our first quartile is 26. 38 is our third quartile, because if I ignore this half of the data, including the median, my middle number is 26. And then if I ignore the first half of the data, including the median, my third quartile, 38, is going to be the middle number of these 5 numbers. So now that I have my third and first quartile to figure out my IQR, we're going to go through and do 38 minus 26, and we end up with an IQR of 12. So we went through and calculated the mean, median, IQR, and standard deviation I gave you guys. So it would want you to go through and compare the data, so which one has a larger mean or median, IQR, or standard deviation, which one has a smaller data set, which one's closer together. If the numbers for IQR and standard deviation are smaller, that means the data set is closer together. Okay, the larger those numbers are, the more spread out the numbers are, and not how close they are to each other. So, with that said, that is how we go through and do example 2. And now we are going to move on to our last part of our notes for today. And that is going to be talking about data distribution. So, data distribution can be described as symmetric, skewed to the left or skewed to the right. And that is what we see drawn on these dot plots. So, symmetric is where we have a symmetrical dot plot, where in general it's the same shape going left to right or right to left. So this one looks like a triangle or a pyramid. Symmetric to the left, or skewed to the left, sorry, not symmetric to the left, but skewed to the left means that it trails off to the left. If your data trails off to the left, it has like a tail to one side, and it's to the left, that means that it's skewed to the left. Symmetric we have the proper shape. Skewed to the right means that the data trails off to the right. So anytime that you have a little trail going one way, left or right, that is going to indicate that it's skewed either to the right or left. If you don't have that trail, then it's symmetric. So with that said, let's go ahead and take a look at example 3, part A, where they want us to go through and make a dot plot for each problem, and then we need to go through and determine the type of distribution. So whether it's skewed to the left, symmetric, or skewed to the right. Now, for example 3A, so we have number of apples sold, and then grocery store A and B. These numbers here indicate how many apples were sold for 0, 50, 100, 150, 200, 250, and 300. So 8 indicates that 8 sets of 100 apples were sold at grocery store A. So that does not mean that we put a dot at 8, but that we put 8 dots at 100. So for 0, it's going to be 1. 50 is 4. So 1, 2, 3, 4. At 100, it's going to be 8. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. At 150, it's 8. So 1, 2, 3, 4, 5, 6, 7, 8. 200, it's 4. 250 is 1. And then 300 is 0. So that is our first dot plot. Let's go ahead and make our dot plot for grocery store B. So that's what we want to focus on next. So at 0, it's 3. For 50, it's 6. At 100, it's 8. At 150, it's 8. At 200, it's 2. 250, it's 2. And then 300, it's 1. So those are our two dot plots for this situation. Now we need to just go through and determine whether the data distribution is skewed to the left, symmetric, or skewed to the right. So if we look at grocery store A, what would you say that is? Okay, this one is symmetric because it's the same on the left and on the right, and there's no trailing one way or the other, so this one is just symmetric. Now, if we look at grocery store B, so we have most of our data here, and there's a little trail this way. Anytime that you have a trail, that's going to indicate skewed. So we just have to ask ourselves, is the trail going to the right or is it going to the left? So the trail goes off to the right, so that means this is skewed to the right. And that is our answer for example 3, part A. All right, lastly, all we have to do is run through part B just to give us one more example of dot plot and then determining the type of distribution. So if we look at part B, so for part B, we have free throws shot and the members of team A and B. So if we look at team A, we have the different sets of 0, 2, 4, 6, 8. For 0 free throws shot, we have 2. For 2 free throws shot, we have 2. 4 is 4. 6 is 2. And then 8 is 2 as well. All right, then for team B, we have 3 at 0, 4 at 2, 2 at 4, 2 at 6, and then 1 at 8. So if we look at team A, would you say that the data is symmetric or skewed to the left or right? Team A is going to be symmetric. And then team B, because we have kind of more of a clumping of data on the left side and then it trails off to the right, this is going to indicate skewed to the right. And that is our answer for example 3, and how we go through make a data set using or how to represent a data set using a dot plot, and then going through and determining if it's symmetric and then skewed to the right or left. So with that said, that is it for our notes on section 9.2 and how you make a dot plot. Then you look and determine if something is an outlier or not, going through and calculating mean, median, IQR, standard deviation to compare data sets, and then also going through making a dot plot and determining the data distribution. So with that said, that is it for section 9.2 for our notes today on data distributions and outliers. Thank you guys for listening. As always, when you work through your homework, reference back to the video or look at my completed notes. If you have any questions or need any help, just shoot me an email or let me know the next time you see me. Otherwise, that is it for today. So thank you guys for listening. Have a great rest of your day, and I'll talk to you guys later. All right, bye.